So we are going to see about vectors. So vectors, before moving into that, we have to know what are the physical quantities. So physical quantities, the quantity which we can measure physically, like speed, temperature, speed, time, work, these are all known as the physical quantities. So that physical quantities which has the magnitude. So there are two types of quantities here. One is a scalar quantity and the other one is vector quantity. So before knowing into vector, we have to know what is scalar. A scalar, the quantity which has magnitude only, but vector is a quantity that has both magnitude as well as the direction. Those quantities are known as vector quantity. So for example, the example of the scalar quantity are mass, time, speed. These were the quantities, physical quantities, which have only the magnitude, but the vectors like such as force, velocity and torque, these were the type of quantities which has both magnitude as well as the direction. So how we are going to represent the vector? So a vector is represented by a letter and an arrow mark. For example, if I have to represent the force, it should be as F vector, or velocity, it can be represented V vector, torque tau vector. So the vector, this arrow mark represents the direction of that quantity. So for example, and also whenever I am just describing it graphically, we always need a reference line, as well as from the reference line in which angle it has been oriented. For example, let us take an object is moving in one particular direction. So we have to consider a frame of reference like x and y, and consider an object is moving in one particular directions, and the magnitude of that will be a, and it has an angle theta from the positive x-axis. So this length, I mean the length of this line, that represents the magnitude of that quantity, and also the arrow mark represents at which direction it is moving, and it is making some angle with some reference line. Here the reference line has been considered as the x. So these were the things which we have to know before jumping into the vectors. There are different types of vectors we are going to see. The types of vector, the first one, let us consider a like vector. A like vector means we are just let us consider we are having two vectors or two or more vectors. Let us consider a vector, b vector and c vector. When these vectors are moving in same direction irrespective of its magnitude. So as I said earlier, the length of the arrow mark represents that it has some magnitude. So when I compare to a and b is greater, and when I compare to c and a, c is greater. So this length of the line represents the magnitude and the arrow mark represents the direction. Like vector means the vectors which is traveling in the same direction irrespective of their magnitude. Those are known as like vectors. And the second one, which is unlike vectors. Unlike vector means the vectors should be, it need not to have the same magnitude, but it will be moving in opposite direction. Those are known as unlike vectors. And in case of equal vectors, so equal vectors in the sense, the two or more vectors, actually if it is having the same magnitude and also it is traveling in same direction, those are known as equal vectors. The fourth one, if we are saying a zero or null vector, so there is no vector which is having zero or null. It depends upon the arithmetic operations. Like for example, let us consider we are having two vectors, a vector and b vector. If I am doing the arithmetic operation of a vector minus b vector, suppose if the magnitude of the two vectors are same, if I subtract it, I will be getting the value as 0, right? So this type of vector, that means when I perform this operation, I will getting the thing which is known as 0 vector. That is known as the 0 or null vector. So this position of, for example, if I consider the x and y axis, the position of this 0 vector will be on the origin, because where it starts there itself it ends. So it will be a position on the origin. We will be saying that its position vector of the origin. Okay, and there is a next thing. What is the number? It is a fifth one, which is known as the negative vector. So negative vector is strictly opposite to the equal vectors. What we saw in equal vectors, we are having two vectors which is having the same magnitude and moving in the same direction. In case of negative, it will be having the same magnitude but moves in opposite direction. That is known as the negative vectors. Parallel or collinear vectors. The next one is parallel or collinear. So which means these two vectors, like, they will be moving along the same line of action. For example, let us consider a vector here and consider it as b vector. So all the magnitudes can be different. So for example, the two vectors, this b vector, that can be represented as a scalar multiple of a vector, which means they are collinear. That means they are moving in the same line. So that are known as parallel or collinear vectors. And the seventh one, which is coplanar vectors. The two vectors, which may be a vector and b vector, which will be always in a same plane. We can do all the operations only if the two vectors are in the same plane. If not, we couldn't be able to do that. So coplanar, which means it's two vectors which is on the same plane, and as well as when I take another plane which is parallel to this vector. So consider here we are having c vectors. Either these two planes are parallel, we can say a, b and c are coplanar vectors. Or when the two vectors are in the same plane, either they have to be in same plane or the vector should be in the plane which is parallel to the first plane. Those are known as coplanar vectors. And the eighth one, we will say that as a position vector. For example, let us consider that we are in a frame of reference. Consider it as x-axis and y-axis. We know we are just considering this point O as the origin, and from here let us consider any point here. So I am considering a point A vector. So like from the fixed origin, the any point in this frame of reference can be like represented from here with the vector. So that vector OA vector is known as the position vector of this particular point. Let us consider a point B here on this space. Let us consider this as B, and from origin it can be represented by this vector to this point. So it will be OB vector. So OB vector is the position vector of the point B. So this is represented as simply R vector. So R vector represents the position vector which is equal to OA vector, and R vector will be OB vector. Usually we will represent this position vector in terms of R vector. And the ninth one. So let us consider a localized vector. So localized vector means in a plane there is a vector. So consider it as a vector. So I am going to draw another vector with respect to a vector. So B vector. So with respect to a somewhere specified point, with respect to this already present a vector, those kind of vectors are known as localized vectors. And the next one, a free vector. So free vector means we don't know where it has its origin. So somewhere we don't know its point. Its initial point is not particularly described or particularly mentioned. Those kind of vectors are known as free vectors. So it can we change these positions, that won't affect the nature of this vector because we don't know from where it is coming. So those kind of vectors are known as free vectors. And co-initial vectors. So co-initial vectors means when the two vectors or two or more vectors are having the same initial point, those vectors are known as co-initial vectors. And unit vectors finally. unit vectors in the sense that if the magnitude of the vector is equal to 1, those are known as unit vectors. The unit vectors is represented by a cap, or we will be saying this as a hat. This a cap can be calculated by the formula a vector divided by modulus of a vector. This is the formula to calculate unit vector. So about unit vector we will see clearly in the next